Statistics Lesson 7.1, Estimating a Population Proportion. 3 objectives. Construct a confidence interval estimate of a population proportion and interpret such confidence interval estimates. 2. Identify the requirements necessary for the procedure that is used and determine whether those requirements are satisfied. 3. Develop the ability to determine the sample size necessary to estimate a population proportion. Key concept. This section presents methods for using a sample proportion to make an inference about the value of the corresponding population proportion. Point estimate. The sample proportion, p hat, is the best point estimate of the population proportion, p. Confidence interval. We can use a sample proportion to construct a confidence interval estimate of the true value of a population proportion. And we should know how to construct and interpret such confidence intervals. Sample size. We should know how to find the sample size necessary to estimate a population proportion. Point estimate p hat, a single value used to estimate a population parameter. We use p hat as the point estimate of p because it is unbiased and it is the most consistent of the estimators that can be used. By unbiased, we mean it tends to have a mean that is equal to the mean of the population parameter. The sample proportion p hat is the most consistent estimator of p in the sense that the standard deviation of the sample proportions tend to be smaller than the standard deviations of other unbiased estimators of p. Example, according to a Gallup poll in which 1,487 adults were surveyed, 43% of them said that they have a Facebook page. Based on that result, find the best point estimate of the proportion of all adults who have a Facebook page. So in this case here, we would say the best point estimate of p is 0.43. We might write p hat is 0.43. Okay? Confidence interval. Why do we need that? On the previous slide, we saw that 0.43 is our best point estimate of the population proportion p, but we have no indication of how good that best estimate is. A confidence interval gives us a much better sense of how good that estimate is. Confidence interval, sometimes called an interval estimate, is a range or an interval of values used to estimate the true value of a population parameter. A confidence interval is sometimes abbreviated CI. Confidence level is the probability 1 minus alpha, such as 0.95 or 95%, that the confidence interval actually does contain the population parameter. Assuming that the estimation process is repeated a large number of times. Degree of confidence, confidence coefficient. Here are the 3 most common. 90% confidence level, so an alpha of 0.10, 95% confidence level, or alpha equals 0.05, and a 99% confidence interval, or alpha equals 0.01. Interpreting a confidence level. So here we have one, 0.405 is less than p is less than 0.455. Alpha equals 0.05. The correct way to interpret this is we are 95% confident that the interval from 0.405 to 0.455 actually does contain the true value of the population proportion p. What we are saying is with a 95% confidence level, we expect 19 out of 20 confidence intervals to contain the true value of P. Okay, if we did it this way here. Wrong. There is a 95% chance that the true value of P will fall between 0.405 and 0.455. That's not true, okay? We're saying that 95% of the time, using the same process, we'll get something between 0.405 and 0.455. Wrong. 95% of the samples will fall between 0.405 and 0.455. So it's a slippery slope. Critical values are based on the following observation. When certain requirements are met, the sampling distribution of sample proportions can be approximated by a normal distribution. A z-score associated with a sample proportion has a probability of alpha divided by 2 of falling in the right tail portion of the normal distribution. The z-score at the boundary of the right tail region is commonly denoted by z sub alpha divided by 2 and is referred to as a critical value because it is on the borderline separating z-scores that are significantly high. So if it's right-tailed, it would be over here, and that would be alpha divided by 2, and that would be the critical region. Left-tailed, it would be over here, alpha divided by 2, and that would be the, and if it's two-tailed, it would be on both, okay? And of course, here in the center, you would have z equals 0. Okay, let's try a little sample here. Critical value is the number on the borderline separating sample statistics that are significantly high or significantly low from those that are not significant. The number z sub alpha divided by 2 is a critical value that is a z-score with the property that it is at the border that separates an area of alpha divided by 2 in the right tail of the standard normal distribution. All right, so here's a table with the most common ones. And let's see here. Here's an example. Find the critical value of z sub alpha divided by 2 corresponding to a 95% confidence interval. Okay, so we got over here and we got over here. Alpha divided by 2 equals 0.025, and over here alpha divided by 2 equals 0.025. Okay, so this is the critical area. This is the z-score is z equals negative 1.96 and z equals 1.96, with, of course, here in the middle, that would be z equals 0. Now, you could kind of extend this up, and what you're saying is the confidence level is 95%. Okay, so this is that's the range that it would be in. Still kind of confusing. Margin of error. When data from a simple random sample are used to estimate a population proportion P, the difference between the sample proportion P hat and the population proportion P is an error. The maximum likely amount of that error is the margin of error, denoted by the capital letter E. There is a probability of 1 minus alpha, such as 0.95, that the difference between p hat and p is E or less. The margin of error E is also called the maximum error of the estimate and can be found by multiplying the critical value and the estimated standard deviation of sample proportions. Okay, I put this equation here into your notes. You're going to use it. You're going to use it a lot. Okay. Key elements. Objective. Construct a confidence interval used to estimate a population P. Now we have several notations here. And let's see. There it is. P equals the population proportion. Okay. P hat is the sample proportion. N is the number of sample values. E is the margin of error. And let's see, so E equals alpha divided by 2 and the square root of P hat times Q hat divided by N. And then let's see, and Z sub alpha divided by 2 is the critical value. So the requirements. The sample is a simple random sample. Conditions. The conditions for the binomial distribution are satisfied. Fixed number of trials. Trials are independent. 2 categories of outcomes, success and failure. And the probabilities remain constant for each trial. There are at least 5 successes and at least 5 failures. And that's that NP is greater than 5 and NQ is greater than 5. And that's the way to verify that. Confidence interval estimate of P. So here's the formula. P minus the margin of error, P hat minus the margin of error is less than P is less than P hat plus the margin of error, where the margin of error equals Z sub A alpha divided by 2 times the square root of P hat times Q hat divided by N. The confidence interval is often expressed in the following 2 equivalent formats. P hat plus or minus E, or P hat minus E and P hat plus E. Round off rule. Round the confidence interval limits for P to 3 significant digits. Procedure for constructing a confidence interval for P. 1. Verify the requirements are satisfied. Find the critical value Z sub alpha divided by 2. Evaluate the margin of error. E equals Z sub alpha divided by 2 times the square root of P hat times Q hat divided by N. Using the calculated value of E and the value of P hat, find the values of the confidence interval limits P hat minus E and P hat plus E, or the margin of error. Substitute those values in the general format for the confidence interval. Round the resulting confidence interval limits to 3 significant digits. Example, in a Gallup poll of 1,487 adults, 43% said they have a Facebook page. So we want to find the margin of error E that corresponds to a 95% confidence interval. Okay, well, we need to do a requirement check. Okay, what were the requirements? What were the requirements? The sample is a simple random sample. The conditions for the binomial distribution are satisfied, and there are at least 5 successes and at least 5 failures. Okay, well, Gallup usually does pretty good with theirs, but I mean, you really wouldn't know. So what you're going to have to do, N, well, let's do it up here. NP is greater than 5, and NQ is greater than 5. Okay, so we're going to have, let's see, 1487. Let me get my calculator. 1487 times 0.43, and that's quite 639. And since Q is larger, it's going to be even larger than that. So the requirements are met. So now let's find the margin of error E that corresponds to a 95. So we've got E equals Z sub 0. Well, that would be 0.5 divided by 2 times the square root of P hat times Q hat divided by N. So we're going to have 1.96 times the square root of 0.43 times 0.57 over 1,487. All right. Y'all go ahead and do that in your head. I'm going to have to use a calculator. And we got, let's see, P hat, that's 0.43 times 0.57 over 1487. And I get 0.2516. So I got equals 0.021564, and it actually goes a little bit further than that. Find the 95% confidence interval estimate of the population P, of the population proportion P. Well, I got a typo there too. All right, so what are we looking for here? We're looking for, and I'm going to have to do it down here, B, that's going to be P hat minus E is less than P, which is less than P hat plus E. So I'm going to have 0.43 minus 0.021564 is less than P is less than 0.43 plus 0.021564. That's supposed to be a 1. All right, so I'm going to go back to my calculator, and I'm going to say 0.43 minus, and I'm just going to go back up there and grab that so I don't have to worry about the round C. I told you. All right, so we're going to have 0.4048. So 0.4048, so I'm going to go 405. 405 is less than P is less than, and then now I'm going to 0.43 plus, and again I'm going to go up and grab that, and I got 0.455. 0.455. Okay, so there's our 0.405 is less than P, and that's going to look like an 8. We don't want is less than P is less than 0.455. Okay, so what are we trying to say here? What are we trying to say here? We're saying, in theory, in 95% of such polls, the percentage should differ by no more than 2.5 points. Okay, by no more than 2.5 points. What about C here? Based on the results, can we safely conclude that fewer than 50% of the adults have Facebook pages? And I would say, based on the confidence interval we obtained, it does appear that fewer than 50% of adults have a Facebook page because of the interval of values from 0.405 to 0.455 are less than 0.5. Okay, not too shabby. So let me put this into words. Based on the, and this above confidence interval, it does appear that fewer than 50% of adults have a Facebook page. All right. And finding the point estimate P, finding the point estimate and E from a confidence interval. If we already know the confidence interval limits, we can find P hat and E as follows. P hat is the upper confidence interval limit plus the lower confidence interval limit divided by 2. E is the upper confidence limit minus the lower confidence limit divided by 2. Okay, in case you're reading an article and you just happen to say, hey, I'd like to know. Here's a way to do it. All right, so the article High-Dose Nicotine Patch Therapy by Dale Hurt et al. Includes a statement. Of the 71 subjects, 70% were absent from smoking at 8 weeks, 95% confidence interval, 58 to 81%. So let's use that statement to find the point estimate for P hat and the margin of error. So let's find it for P hat. P hat equals, and then we got 0.81 plus 0.58 divided by 2, and that is 0.695. 695. All right. And then let's see, now we need to find E. E, and that's going to be 0.81 minus 0.58 divided by 2, and that equals 0.115. All right. So we found them. Determining sample size. Objective. Determine how large the sample size N should be in order to estimate the population proportion P. Okay, several notation. We've already done these. We did them before. It's the same. P is the population proportion. P hat is the sample proportion. N is the number of samples. E is the margin of error. And Z sub alpha divided by 2 is the critical value. Requirements. The sample must be a random sample of independent sample units. 2 formulas. When an estimate P hat is known, use N equals Z sub alpha divided by 2 squared times P hat times Q hat divided by E squared. When no estimate P hat is known, same formula, but we substitute P hat and Q hat for 0.25. Okay. Round off rule. If the computed sample size N is not a whole number, round the value of N up to the next larger whole number. So the sample size is sufficient instead of being slightly insufficient. So we're not rounding to 3 or 4 places on this. We're rounding up to the next whole number. There are other methods for constructing confidence intervals that we have not discussed here. There isn't mutual agreement on which method is best for constructing interval estimates of P. What we've been doing is the Wald confidence interval, and it is best as a teaching tool for introducing students to confidence intervals. Example, suppose there is no information about the percentage of adults who make online purchases. Yet that information would be extremely important to online stores and brick and mortar stores. If you were to conduct your own survey, how many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points? Okay? Now, here is a mistake that a lot of people make. 3 percentage points. That is not 3, that is 0.03. Okay? 0.03. Be careful with that. So, A, assume that a recent poll showed that 80% of adults make online purchases. So that would give you P hat equals 0.80. Okay? And so Q hat would be 0.20. And our error, margin of error, is 0.03. And we're using 95%, so we've got Z sub alpha divided by 2 is going to be 1.96. Okay? So N equals, and that's Z sub alpha divided by 2 squared times P hat times Q hat divided by E squared. And this equals 1.96 squared times 0.80 times 0.20 over, and we have 0.03 squared. Okay, let's put that in our calculator and see what we get. Control, divide, let's see here, 1.96, close parentheses, squared, times 0.8 times 0.2 over 0.03 squared. And we get 682.951 equals 682.951, or that's a 9 and that's a 5, or 683. Okay, so your n needs to be 683. You need to poll 683 people. Suppose there's no information of adults who make online purchases, yet that information would be extremely important to online stores and brick and mortar stores. If you were to conduct your own survey, how many adults must be surveyed in order to be 95% confident that the sample is in error by no more than 3 percentage points? Okay, so what do we got here? What is p hat? We don't know. So that means we don't know what q hat is either, right? We do know that E is, well, it said 3 percentage points, so that's going to be 0.03. We're looking, and we know Z sub alpha divided by 2 is 1.96. All right, we got that off the table, 1.9. You know, what if you don't happen to have a table? What if you don't happen to have a table close by? How would you find out without a table? Or say we didn't remember. All right, let's see here. What if we went menu, 553, in the area, we would say 1 minus 0.95, and that gives us 1 minus, that gives us negative 1. Hold on, we just said 0. Oh, so we couldn't do it that way. Menu 553. What do we got? What do we got? Open parentheses, 1 minus 0.95, close parentheses, divide by 2. Try that. 1.96. All right, I know it says negative, but remember it. If this is negative 1.96, this over here is 1.96. Okay, it is symmetric. All right, good. So now let's find n equals, and that's going to be z sub alpha divided by 2 squared times 0.25 over e squared. So we're going to have 1.96 times 0.25, and that's supposed to be squared. That looks terrible. Let me fix that. 1.96 squared times 0.25 over 0.03 squared. So let's try that. Control divide. 1.96 times 0.25 over 0.03 squared, and we get 1067.11 equals 1067.11, or 1068. So you would need to survey 1,068. Okay. Now, what some people do is they get a number like that, and then they survey 30% of them or something like that, and then they calculate their p-hat, and then they go from there and figure out how many more they need to survey. All right. Good job, folks. Thank you very much for your time. You have a wonderful evening. I'll see you in class tomorrow.